So what we're going to do is leverage an existing thing that you should already know in order to factorise quadratics. And the thing you should already know is the rule about squares. Actually, there's two things, but the first one is this. A plus b squared is a squared plus 2ab plus b squared. So what we're going to do is take our quadratic and use just the first two terms, the x squared term and the x term, and try to add something else to make it look like this. Because if we can do that, then we can, effectively, we're completing the square, and we can then factorise like this. And that gives us a way to solve later on, but we're just going to practice completing the square first. So, for example, some of them will already be in the right form. Let me show you. X squared plus 6x plus 9, for example, is going to be x squared plus 2 times 3x plus 3 squared. So this is x squared 2 times x times 3 plus 3 squared. See how that works? Let me actually write it out. X squared plus 2 times x times 3 plus 3 squared. And that means I can apply my rule and just write x plus 3 squared. Let me try another, but I'll leave it for you to complete. X squared plus 8x plus, 8x plus what? What do I put here to complete this square? Well, I need it to be x squared plus 2 times x times, that's that x, times 4. So I'm going to have to add 4 squared, which is x plus 4 squared. Now there is a trick to this. This is 2 times x times the thing I want. So this thing I want is always this divided by 2. Always. So let me try one more that way. X squared plus 12x plus something. Well, the something is always going to be 12 on 2, 6 squared. I'll show you why that works. It's x squared plus 2 times x times what gives me 12 has to be 6. See why that worked? And so it's x plus 6 all squared. Okay, but how does this help me to actually factorise a quadratic? Well, suppose I start with this one. X squared plus 6x plus 1. Now the thing is, we already know how to how to complete the square of x squared plus 6x. We're going to add half of this squared, 3 squared. But we've got a plus 1 here. Now here's the secret. Complete the square. I'm going to leave room to complete the square and leave the plus 1. Leave a nice long gap because we're going to put 2 things in here. The first is I'm going to complete the square for this. And the square for this will be completed by adding 6 on 2, or 3, squared. That makes that a perfect square. But I can't just randomly add 9 and say it's equal. I have to then subtract the same 9. So what I've done is I've made a space, moved that along, I've completed the square, and then I've subtracted again the thing I just added, so that I've still got it equal. Well, this bit is x plus 3 all squared. And this bit is negative 9 plus 1 is minus 8. Now, here's the other thing you need to remember. This is a difference of two perfect squares. Okay, you might not recognise this as a square, but it's root 8 squared. And the rule was a squared minus b squared is a plus b, a minus b. So we can simply write x plus 3 plus, what was this square root? Root 8, x plus 3 minus root 8. Oops, my 8's very messy. So I've used this rule to factorise this difference of squares by first making this a square. Now I have factorised this expression by completing the square. Normally we would write this without those brackets. X plus 3 plus root 8 and x plus 3 minus root 8. So, to foreshadow what happens later, if this was a quadratic equal to 0 and I was trying to solve it, I would have two possible solutions. One would be negative 3 minus root 8, and the other would be negative 3 plus root 8. Notice those are surd conjugates. Let's try some more. X squared minus 8x minus 3. Well, first complete the square. Minus 3 over here. So I don't forget. I actually always write that minus 3 now so I don't forget it later. Otherwise I'm likely to complete the square and then forget about the minus 3. So I try to do everything up front. Put the minus 3 in way over there. To complete this square, I need to get my 8 and divide it by 2, 4 squared. This will always be a plus term because in the rule, it's always a plus squared. If I had a minus b squared, it's a squared minus 2ab, but it's still always plus b squared. This is always a plus. So I've added 16, so I better subtract the same 16. Otherwise it would no longer be equal. Alright, this is a perfect square. Minus 4 squared. Now I've got minus 16 minus 3 for minus 19. Okay, this isn't a normal perfect square, but I can still use this perfect square rule, difference of squares rule, if I write this as a surd. That is x minus 4 plus root 19 and x minus 4 minus root 19. And again we usually write, we usually write that plus root 19, x minus 4 minus root 19. We usually write it without those inner brackets.